record on this computer. So I'm going to go ahead and boot up IntelliJ. So I hope you had the chance to try to work on problem 2.4. Okay. And if you haven't had the chance to work on 2.4, don't worry. I mentioned that I'd be going over it today. And overall, I do consider it of those the most difficult to. Okay, hold on one second. I need to fix the display. Okay. Display settings. Duplicate desktop on 1 and 3. Keep changes. There we go. All right. By the way, is this big enough for everybody in the back? Yes.
There was no due date for the lab on campus. Is there a due date for this one?
We do like next Monday or so, next Tuesday, I'll probably set the due date. Okay. Sorry that I forgot to set the due date. Because most of these are going to be basically one. Yeah, it would be due on, let's see, yeah, not Monday because that is a holiday. Probably be due on the 6th, end of the day. Okay. Bet you've also got all Friday in lab to work on this too. And I'm giving you one of the 6 now. So, all right. So what is one of that 6? That was the is permutation problem. So it says basically given 2 lists, right? Given 2 lists of stuff. Say we've got so say I've got 1, 2, 3, 1, 2, 3, 1, 3, 2, 2, 3, 1, 1. Check if these two are permutations of each other. Can you see in the back or no? Do you want? Yes? You want? Okay, great. So 1, 2, 3. So 1, 2, 3, 1, 2, 3. So these 2 lists are permutations of each other because they have the same number, because they have the same items and they have the same number of items. This is important because if, for instance, for a more simple example, if I had AAB and ABB, these are not permutations of each other. Permutations have the exact same number of each item in it. So there's 1B in here, 2B's in here. That's a mismatch, right? So it's not as simple as saying, okay, does for each item in A, does it exist in B? Unfortunately. So, and again, we're dealing with these for lists, but the same kind of logic can be moved towards strings. But let's go ahead and start writing the so I'll go ahead and start writing the signature for the method, public Boolean. Sorry, public static Boolean. Public static Boolean. Going to take in type E and is permutation. Is permutation, and we've got two things. A list of E, and I'm going to call it list A, and a list of things called list B. So first off and foremost, all right, I was not expecting a lot of people to solve this when I first made this problem years ago, was is also one of the best ways to solve a problem, but also requires you to learn a bit more because your instinct, if you're familiar with the kind of problem, your instinct is kind of, okay, if I sort these things, that'll be easy to tell if they're permutations, because anything that's a permutation, if you sort it with anything else that's a permutation, then if you sort one thing A and sort thing B, if they come out to be the same, they're permutations. So for instance, this top one comes out to being, you know, 1, 1. There's 2 1s, so it's 1, 1, 2, 2, 3, 3. Pretty easy to sort. Same with this. 1, 1, 2, 2, 3, 3. So those are the same. So those things are the same. Here, they're pretty much already sorted for us, and we can see that they are not the same. Similarly, if we look at words, wolf and flow, well, flow is already sorted, but if we were to sort wolf, it would become flow alphabetically, right? When you sort letters, we sort them alphabetically. So you might go, so if you are doing what I expect you to do in this case, if you come up with this, the next, like you think, and this is good that you think it, if I sort this, this becomes easy. So the next thing you might do, which is what I'd expect you to do, which is good, I'm not saying any of this is bad, okay, is to go, okay, how do I sort things in Java very easily? And your first result will probably be this. It will probably be this function, which is collections.sort. Collections.sort, not collection, which says, given a collection of things, it will sort that thing. It does not return anything because it sorts it in place. And so you'll pass it list A, and you'll get an error. And the error says, required type list T provided list E, reason no types of variable T exist so that E conforms to comparable super T, question mark super T, which is I'm not sure if everybody can read that there. Can everybody see that? It's a bit of a mouthful there. So you might think, okay, does that mean I have to change this type to be T? But no, you'll just get the same error. Or you should get the same error. Let it up. Yeah, now it's updated. Required type list T. You provided list T, but no instances of it. So the answer comes a bit clearer, at least to me, but not necessarily to you because you don't necessarily know this format yet. If I look at the sort method, and one of the fun things about IDEs is that you can hold control or command, and if you're on a Mac, and click on a method, and it'll bring you to the method. If it's a method you wrote, it will jump to where it is in the code. If it's something in the Java source code, it will open up the Java source code. And we can see that over here, it's got all sorts of nonsense. So public static, not T over here, which again, T doesn't matter. T extend comparable question mark super T, which is another generic in itself. We can ignore this part, by the way, right over here for right now. But what this is saying is that question mark super T means it's a subtype of T. In other words, if I were sorting numbers, it'd be fine to compare it to anything that was, sorry, if I was sorting, if T was an integer, I could do anything that was a super type to that. I rarely use this. I used to know this a lot, but I found that I use it so infrequently that it doesn't matter. But and then it calls with that sort with C being none, which is the comparator. So what is comparable? So comparables is an interface which imposes then now I'm using a modern algebra term here, a term for modern algebra, which is called total ordering, which is opposed to a partial ordering. But a total ordering means that if I threw a pile of stuff at you, you'd be able to put it in some kind of order, and that order makes sense. And there's an unambiguous way to sort things. So for instance, if I threw a bunch of numbers at you, it is unambiguous which one about how to sort them. You could sort them from lowest to smallest, highest to smallest doesn't matter, but there is an ordering that is absolute, right? Everything is less than another item. Everything is greater. Everything can have a less than, greater than, and an equal to relationship with any other item. Okay. Same with letters. And comparable is basically Java's way of saying stuff. And what it's saying over here is that if you're going to pass me something to sort, I've got to be able to sort it. I can't sort things that aren't comparable. I can't sort things that don't have a total ordering, which makes sense. If my list was a list of scanners, how in the world would I sort it, right? How'd you sort scanners? I don't know, it's not comparable type. So what we can do over here is that we can enforce that E is comparable. So that list, the only lists it will take are lists that are made of comparable items, like lists of strings, which are comparable. List of integers, which are comparable. Pretty much anything that you would sort is comparable. And the other method that it had, by the way, which said sort collections.sort was sort comparator, which was basically if these things aren't comparable, you can provide some way how you want to sort them. A comparator which tells me how to sort them. That's a bit beyond what we want to do here. But basically, I'm going to go ahead and show you the way that we enforce things to be sortable. And this doesn't come into play until we start writing trees. But I'll present this now. The way we enforce this to be comparable is to do this. Extends comparable E. So I'm going to show, this is the short way to do it. I'm going to show you how to solve this problem multiple ways, because they teach you something different each way. So what this says, E extends comparable E, and you need this here, otherwise you're going to get a warning, not an error, a warning. But basically you're saying is that E is a subclass of the interface comparable. Okay, I know you use implements for interfaces, but not when we're doing generics. Okay, E extends, meaning E is a subclass of comparable. We'll go over what comparable brings to the table for items in just a second, okay? Just now, but basically say, hey, what they're saying is E is an item that is comparable, and this E over here says it's comparable to other E's. Basically, it has to be comparable to other E's. I don't care if it's comparable to other things, but for the purposes of this discussion right here, for this method, it needs to be comparable to other things that are here. So in other words, numbers are comparable to other numbers, so that's fine. Strings are comparables to other strings. So that's how it sorts it out. So this method becomes collections.sort list A, collections.sort list B, and then ideally you could just check to see if they're the same, which is return list A dot equals, although we should probably check how that implements for a list. Returns the specified object is true if and only if the specified object is also a list, both lists are the same size, and all corresponding pairs of elements in the two lists are equal. In other words, the two lists are defined to be equal if they contain the same elements in the same order. So which is exactly what we want. Awesome. Right? So again, control clicking on things is very useful because it brings up not just the method, but the documentation. So list A dot equals list B. And that's great. That's all we have to do if we do it like that. We'll add one more line here, which will be relevant for any implementation of this, which is that if list A dot size is not equal to list B dot size, then we can immediately reject it. We can immediately say return false, because if they're different sizes, they can't possibly be permutations of each other, because they can't have the same number of the same items. Impossible. Right? Like again, if I had A, B, there is no possible way it can have the same number of items as something of length 3. Okay. So now that I've introduced comparable and talked about it a bit, what does it actually do? So let's go. I'm going to open up a main function to run just so I can show you. So first off, I'm going to make a integer I is equal to 5. And the reason I'm making an integer, actually, I'm going to call it A because I'll be comparing A to B. The reason I have an integer is because I want it to be a class so I can call the comparable function on it, right? Ints don't have functions I can call, but objects do. Okay. integer b is equal to 7 or whatever. And so now I will show you what comparable brings to the table. A, it gives you one access to one function called compare to, which it's 2 words, so it's not, it was, and the 2 is capitalized, so it's not comparato, it's compare to, right? Camel casing. A dot compare to B. And this is kind of just just kind of a check that you can use for if-else statements. So if I run A dot compare to B with A and B set to 5 and 7 respectively, I'll get -1. Now, why is this? So again, the interface, this is checking it for an integer, but compare to comes from the comparable interface. So I'll click on the comparable to open up. So the comparable interface brings to one function, says in order to be comparable, you have to fill out one function, which is compare to, which takes in another object. What does compare to do? It returns one of 3 things: a negative number, 0, or a positive number. If A comes before B, in this context, if A is less than B, if A comes before B in the total ordering, A is less than B in this case, then we get a negative number. If they're equal, then we will get 0, which makes sense, given with the way I've told you what your options are. And then finally, if A is greater than B, we'll get a positive number. For integers, that's the only requirement. For integers, we just use 1, 0, and -1. So for instance, if I were to do this the other way around, compare 7 dot compare to 7,000, right? I'd be getting a negative number because 7 comes before 7,000. But if I do A dot compare to B, 7,000 to 700, I get +1. Okay. Again, anything that's sortable has the compare to function. It's very useful. It really comes in useful when we're dealing with writing trees, but otherwise, I mean, this is pretty much where we'll see it. So also it's worth noting how it works for strings. So string X is equal to apple and string Y is equal to lemon. It still follows the same rules of negative number, 0, or positive number. But just keep in mind, how do we sort things that are words? How are words sorted? String sorted? How would you sort strings? Yes. You'd sort them alphabetically. Yeah. In other words, dictionary order. Now, although remember, capital letters do make a difference, right? Capitalization versus lowercase, but regardless, when you're sorting words, generally you're generally filtering out those capitals. Yes.
Capitals are ASCII values.
Pretty much. ASCII values are more common in these cases because languages now support it. Unicode. In other words, there's nothing stopping you from writing in language or emojis for these and doing comparatives on those. But anyway, let me run this. Apple. So we should get a negative number because apple. Oh, actually, we should get a negative number because apple comes before lemon in the dictionary, right? A comes before L. So we'll get a negative number. And remember, you can think of it as less than or comes before. But it's not going to give us -1. It's going to give us -11. It's going to give us a dictionary distance. Okay, which is useful in some contexts, but we don't need to know about that. All we care about for the purpose of sorting is whether it's negative or positive, and all it has to do is follow those rules. Okay, this is useful when you're trying to figure out how different words are. But but we don't need to know it. Just know that you have some, because it's negative number, it was designed with some flexibility in mind. There's nothing stopping for the, for integers, instead of reporting a negative just -1, reporting the difference. But that's how you solve that one the short way, if you thought about going it that route. Again, the reason we needed this was because without it, it would just simply crash. I'm going to call this is permutation by sorting. I'm going to go ahead and copy what we have. And now I'm going to solve this the manual way, which is the way that you are going to try solving it without doing that. And it's useful because, again, this checks if they're if it would only work on, it would work on most things, but it wouldn't work on, like, saying if lists of objects are the same, because objects aren't necessarily comparable, right? If E was like the most generic type of all object, it can work there. So let's go ahead and try. So what I'm going to do here is I'm going to assume that these are permutations, and I'm going to try to disprove it. So the way I'm going to go about this is a weird looking for loop. Okay. Oh yes, I need to change the name to is permutation instead, so that we don't have a clash of two names. So first thing I'm going to do is do that same check that I put in at the end, which is checking to see if the two sizes are equal. Because if they're not equal, then I can throw it out. And now I can basically assume, make a lot of useful assumptions, or rather I can avoid a lot of unnecessary checks. So my strategy is I'm going to go through every item in list A. And then I'm going to count the number of times that item appears in list A. And then I'm going to count the number of times it appears in list B. And if those counts are equal, then I'll just keep moving on. But if those counts are not equal, that means that like we're in this situation over here where we've got two A's in one and one A in the other, which means they can't be permutations. Now, because of that, because it's the whole for each item in list A, I count the number of times it appears in A, and then I count the number of times it appears in B. That's a weird looking for loop you may not have gone over, because in the loop where you're iterating over something, you're going to iterate over that list again. So it's useful. So I find it organizationally useful in this case to use the for each loop. So for each item in list A, I'm going to go ahead and iterate over it, list A and list B. So for every item, I'm going to create a int count A is equal to 0. So count the number of times it occurs in A, count the number of times it occurs in B, and then do the actual counting in the middle, which there's a couple different ways to do that, but I'm going to go ahead and do it manually. And then at the end, I'll ask, hey, if count A is not equal to count B, then return false. If I've got a count mismatch, then I'll return false. Otherwise, I'll just go on to the next item. So to count, if I've got an item, to count the number of times it appears in list A is fairly simple. Here's another kind of autocomplete that happens in this. So I type for I and hit tab. It writes most of the for loop for me. For int I is equal to 0, I is less than, what do you want? And then I is equal than I++, which is the most common for loop that you want. In this case, again, I'm going to say I'm going to do list A dot size. Now, this happened a couple times. I got this question I got this question from a lot of people on Tuesday. And because I got it from a lot of people, it makes it a perfect target to put on an exam, which is, it's like a lot of people were trying dot length or dot length with parentheses. Java is very annoying versus Python in regard. If I wanted to know how big a list was in Python, I would just simply do len of L, and that tells me how big L is. But if I want to know how big a list, but for Python, oh boy, If it's an array, if it's some array, it's dot length without parentheses. If it's a string, then it's dot length with parentheses. And if it's a list, though, or anything else that we deal with, some kind of collection, everything we're basically teaching in this class is going to be dot size. Why is this? Well, because arrays do have, because it was a choice by, it comes down to basically stylistic choices and syntactical choices by the people who made the language. For Python, it's like, yes, len, and we'll just overload the meaning of the word length. Yes, some collections don't have a length, but we don't care. It's 3 letters long, and I can use one command for everything now. Arrays have a length, strings have a length, sure, lists have a length, but not all collections do have a length. What some collections have are the size, like sets. When we get to those, you'll see that those don't have a length. They're just a pile of objects. Same with hash maps and hash maps, they don't have a length, they just have how many items are in it. Same with trees. They don't really have a length. They have a height, but that's way different than a length. So for these objects, they were like size is most generic, so we'll use that. So for every I equals 0, I is less than list.size. Basically, what we'll do is we'll say if list a dot get I, so that the item at index I is equal to dot equals the item that we're looking for, then we'll say count a plus plus. So for every item in list A, if it's equal to the item that we're looking for, then we increment it. Then we do the same thing for list B, which is easy enough because I'll just simply copy this, paste this, change all the A's to B's over here. B, B, B. And that is actually all I need to do in this case. Although I need to know why I'm getting some errors over here. Looks like void string args. Why is it saying? Did I accidentally quash something that I shouldn't have? Ah, I accidentally have something. Yes, I have a semicolon missing, a curly brace missing. So boom. Source of a lot of odd errors. Okay, so curly brace. So here we go, for loop, and we count them. And that's all we need to do. We don't have to iterate for every item in list B and then have 2 lists in that, because they're the same size, because we know list A and list B are the same size. So if they're the same size, right? If these 2 things are the same size, okay, then yeah, no need to take pictures. I'm going to just go ahead and drop this on Discord. That seems to make sense. So if list A and list B are the same size, then if there's a mismatch, then it will become apparent from just checking list A. So let's see. So I'm going to go ahead and copy this. And I'm going to go into Discord. I'm going to go to, let's see, where is my class? I'm going to go to 2168, and I'm going to drop this in the Discord channel, because that is the easiest way to get it for me to get it to you. Yes. What? How do I do that again? Oh, it's this thing, right? Like that, and then what? Java over here? Ah. Got it. Very useful. This is why I like, I knew that was a thing you could do. I just didn't know I knew how to do it off the top of my head. But it's super useful. There we go. Thank you so much for that. So now it's there in Discord for you to grab. Very easy very easy way for me to distribute it other than like sending it out via email. But email has its own things with code and copy and pasting and. All right. So that's that one. Now for the last problem, that is the trickiest of the bunch. And I urge you to make sure that you run it on the example I have set up. Okay? So the example specifically with a bunch of 5s in it and trying to remove all the 5s. All right.